north of the pass at the Green River Formation, there was a lot of relief still. So the sedimentary rocks that were at the pass are down here, tilted down to the north. And then the Green River Formation had a lot of erosion right in here that would have to have actually occurred well above the pass at one time. So to put it all together, the San Rafael Swell centers out in here. Here's Price, Utah. And here's the dip of the beds right here. Here's the pass right here. And the relief about 600 meters or 800 meters. It could be right in here. But from the pass on down, you can just use trigonometry and a dip of 8 degrees. Anyway, when you add up all these factors, this is the erosion I got over the San Rafael Swell. 4,200 if the dip is 6 degrees to 5,100 meters if the dip is 8 degrees, which I think is the true dip. So 5,000 feet of erosion over the San Rafael Swell. Okay. Looking at this a little deeper, the Green River Formation forms the top formation in this sequence. So for the Green River Formation to be a post-flood lake, you'd have to deposit all this sediment right in here, generally flat over the area. And then it bows up into the San Rafael Swell and the center gets eroded. 5,000 meters about gets eroded, leaving the Green River Formation at the very top. How likely is this after the flood? I'll repeat this. First of all, if the Green River Formation is a post-flood lake, it has to form on top of these other formations, which presumably be from the flood, several thousand feet thick, or maybe 1,000 meters thick. On top, it'd have to be deposited first, and then it has to bow up, and then much of this was eroded over 3,000 square kilometers, all after the flood. And by the way, the erosional material is gone. It's nowhere found on the continents. It's been eroded like many other areas of the continents, completely off the continent, except for maybe some coastal basins like in southern Texas. But it's mostly been deposited on the continental margin, forming the continental margin that forms the continental slope, and the shelf, slope, and the slope. That's where you find the material. That's a flood signature, obvious flood signature. I can't stress this more. The Green River Formation is a flood deposit. Now, the reason that a lot of some creation scientists like to say it's from a post-flood lake is because of where they put the post-flood boundary. I've been studying this for 25 years from various areas of geology and some areas of atmospheric science like climate evidence and miscellaneous. Anyway, this is a table of 33 evidences that the post-flood boundaries in the late Cenozoic. Those that believe the Green River Formation is a post-flood lake put the post-flood boundary down near the Cretaceous Tertiary or the Cretaceous Paleogene or Cretaceous Paleocene. It's all the same. Or maybe a little above, or vary some in there. And so as a result, they have to suggest or claim that much of the Cenozoic is post-flood, including the Green River Formation, the origin of Grand Canyon, the thousands of water gaps across the earth, planation surfaces, long transported quartzites, and many other features they have to say formed after the flood. But when you look at these features, there's 33, there's even more. Tim Clary has done more research and added 2 more to these, which aren't here. And the strength is an arbitrary value, considering how well those who believe the flood post-flood boundaries at the Cretaceous tertiary boundary, how well they can explain it. I'm just going to mention a few of these, like thick, pure coal seams. You have a lot of thick, pure coal seams in the Cenozoic, clear up into the Miocene, which is considered the late Cenozoic. And coal seams are no way can they form, hate to be dogmatic, but when you think about trying to form a coal seam after the flood, it just blows your mind. These are flood features from the floating log mats and the deposition of this vegetation in various areas within the sedimentary rock column. The sediments were increasing rapidly. So the thick, pure coal seams, number 9 there, the fact that you have so much Cenozoic coal, some of these coal seams, like in the Powder River Basin, which I believe John Whitmore and others think is post-flood, are 200 feet thick of almost pure coal. How could these form after the flood? Now, obviously, I believe a flood signature. Also, tectonic evidence. It's significant vertical tectonics in the Cenozoic, especially late in the Cenozoic. You had evidence of mountains going up 40,000 feet versus the basins that sank. All over through the Rocky Mountains, from mid to late Cenozoic, you had the huge uplift and sinking of the basins in between. According to Psalm 104:8, the mountains rose, the valleys sank down to drain the floodwaters where God placed them. So how can all this tectonics occur after the flood? And then there's a significant erosion of the continents, geomorphic evidence. For instance, how much erosion occurred on the continents? I've just been figuring this out just recently. Based on the amount of sediments in the oceans, they now have a good calculation. And I had to figure out how much was deposited from post-flood river also, and from post-flood ice age a deposition of microorganisms. But a conservative estimate is 1,900 meters were eroded off during the recessional stage of the flood. 1,900 meters. It's mostly along the continental margins, which can be up to 18 to 20 kilometers thick of sediments offshore. So this is a strong signature that this erosion occurred during the recessional stage of the flood. Anyway, and this would occur mostly during the Cenozoic, which would be considered post-flood by some people. So obviously the post-flood boundary is really high in the rock record. It's, I'd say, generally at the Pliocene, Pleistocene, but it can be lower down. For instance, I believe the Australian marsupials are lower down. I have a paper written on that subject that's in review right now. And other areas, I think, are up into the Pleistocene. The Pleistocene is no magic time slot for the Ice Age. It's the Ice Age time frame for the uniformitarian scientist, but it need not be for ours, because there's a lot of Pleistocene sediments in some valleys that are over 1,000 meters thick. And how can this be deposited after the flood? So I believe that 1,000 meters or plus, more than 1,000 meters, is a flood signature, implying that in some places the early Pleistocene is from the flood. Anyway, the boundary is not a magic time within the uniformitarian system, which is an arbitrary system with a lot of problems. So we can use it, which I've done, to bracket the general frame. And so the general frame is anywhere from Miocene to up to Pleistocene for the boundary. And this is strong evidence that the Green River Formation is from the flood, just because of all this other evidence worldwide and from many geological areas, sedimentary rocks, organic evidence, tectonics, geomorphology, and then even from climate evidence. Volcanic winter, for instance, there's those volcanic formation, the Bridger and the Washakie Formation associated with the Green River Formation are volcanic ash, implying a huge amount of volcanism. Well, if this is post-flood, there'd be so much volcanism that you'd cause a volcanic winter if it's post-flood, which would be a problem for those warm climate fossils that they're claimed to be post-flood in the Green River Formation. Anyway, the upshot of this is, to me, the evidence is very clear that it's a flood deposit.